Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows. Super, the incident we're going to talk about today is one that impacted us in the East-West region. It happened in two parts. The first window was limited to one availability zone, I think it was AZ3. And then the second part, there was mostly contained to the zone, but there was sprinkles of a little bit of impact beyond there. There were two separate windows, but it was the same incident overall that caused it. It was on the 18th of March, and then the second window tipped into the 19th of March, 2025. And here we have our engineering experts to talk about it.
That's right. So I'd like to introduce our engineering leaders. First up, we have Lihua Yuan, our Vice President and Distinguished Engineer. Also joining us remotely, we have Frank Ray, our partner and Head of Hyperscale Network Connectivity. Both Lihua and Frank are joining us from our networking engineering team. So thank you both for being here.
Thank you. Super. Before we get into the actual incident itself, Lihua, could you talk to us about the architecture of our network, particularly at a regional level? We talk about, in the PIR, we spoke about how traffic moves intra-zone between zone to zone. Why would customers have this kind of thing? How does traffic flow? How does this usually work?
Yeah. So if you think of from a server, right, connecting all the way to the region level, right, the server is connected to the top of rack switch, then connect to the cluster level devices, and then it connects to further up to the data center level device, right? From a data center level device, within the AZ availability zone, it connects to what we call the AZNG, availability zone network gateway.
And right? I think we've got a diagram to show this as well, yeah. So we can put that up while you're talking us through it.
Yes, please. And then for everything else, right, for going to the edge and going to the WAN and interconnecting things, it goes to what we call the RNG, regional network gateway, right? So the RNG, the regional network gateway, is where the devices are getting connected between the availability zones, right? So for traffic that needs to go between availability zones, they will go through the regional network gateway, right? And for traffic that can stay within the DC or stay within the availability zone, they'll go through the AZNG. So that's a high level of how traffic flows in our network architecture.
Got it. That's great to understand and cool that we can see it there. So those regional network gateways are basically these data centers just for networking, and that's how we kind of route traffic between the data centers and between the zones here. Okay, so Frank, good opportunity for us to bring you in here. Let's fast forward, now that we understand that general architecture, fast forward to the incident on the 18th of March. And really to understand the different factors involved here, there were two different halves, right? There was this first wave of impact that I understand was caused by a third-party fiber cut. And then later on, we'll talk about a second wave of impact caused by our own tooling issues. But can you help us to understand, now that we've looked at that network diagram with Lihua, what was impacted by the initial fiber cut? What traffic couldn't move through the network?
Yeah, so thank you, David. So each of our data centers within any availability zone are connected back up into the RNG, as Lihua mentioned, and there's multiple paths. And in this first impact that we saw, there was work happening outside of Microsoft. Virginia is one of the largest data center markets in the world today, so there's lots of activity on top of general civil works and road expansions that are happening to accommodate the overall population growth that we see in Virginia. And in this instance, there was work happening, not part of anything that Microsoft was doing or even our provider was doing, where digging was happening that hit one of the paths and one of the conduits that carried multiple fiber pairs that connected data centers within the availability zone. And this work then severed the connection that impacted some of the diverse capacity going into a small number of data centers within the availability zone. The data centers were still operational, but the overall capacity amounts were reduced in this case due to this unplanned cut of our fiber paths.
And that was specifically, I know we talk about kind of physical availability zones. We should clarify for customers, you know, that the way that physical zones map to the logical zones that are exposed in the portal might be a little different. But when we say this impacted physical availability zone 3, customers knew that they were in AZ3 or had chosen to be in AZ3, or some customers might have just deployed regional workloads and ended up in AZ3. Is that the right way to think of it, Frank?
Yeah, so, you know, availability zones they're both physical and logical construct within Azure. And in this case, These were fiber paths that were serving data centers that are all part of the both physical and logical construct of availability zone 3. So any traffic that was flowing in and out of availability zone 3 would have been the only traffic that was impacted due to this fiber cut in this first event.
Super. Thank you very much, Frank. It's interesting to know. The other piece that I find fascinating is as we repaired the fiber, that's when the second window happened. And so for me, when I was reading the PIR, it was interesting. Did we not isolate that fiber? Was it just on standby? Because the moment the third-party provider started hooking it back up again, it wasn't fully ready, but traffic started flowing, and then we saw that second window of impact.
Yeah, you're exactly right, Samuel. I think during the first week when the fiber comes down, right? So our automation are actually supposed to come in to completely isolate the fiber to prevent further impact, or actually prevent the fiber from coming back in an unorganized fashion, right? Then due to a software bug, that issue that we have, and it's taking the lock on the devices, it was not successful, right? And so you isolated some of the devices, but partially isolated. It wasn't completely isolating on some other devices, right? So when the fiber comes back, it starts coming back in the unmanaged fashion. So that's exactly where it hits with the tooling issue that we had, right? So that's a cause of the second impact window. Right. So yeah, and then this is still kind of within the availability zone 3, but we have another issue on the RH device, right? With that kind of had a ripple effect. That originally it was supposed to have this containment for everything within the AZ on the RH device, but that containment failed in this situation, right? So that's where we got those ripple effect onto the other availability zone 1 and 2.
Got it. So that RH device is it's like a regional hub,
yeah,
and that helps to connect these different buildings together.
That's
and
right.
Because that was congested, that congestion was then able to spill over into some of the other.
Yeah, exactly right. Yes.
Got it. Even when we talk about this congestion, I mean, I read in the post-incident review, there's very small numbers involved. This was less than 1% of the packets were dropped.
Yes.
Can you help us to understand that was impactful for some customers, maybe not for others?
Yeah. So if you when we talk about RH, right, it's actually not a single device. Right, it is actually multiple devices over multiple fiber span. Right, so during the first impact window, there's actually another device failed before the fiber cut. Right, so that's when it caused a congestion. The congestion is singled on a pair of link. Right, and so if you think of on the grand scheme of things, we have a lot of redundancies and a lot of device in both the device level and the fiber level, right? So this particular set of fiber failed and together with the device caused the congestion on some paths, but not on majority of the other paths. Right, so that's where the overall packet percentage is really low, right? But if you think of our network is really fast, so even a small percentage over large traffic volume, it can be a lot of packet being dropped. But coming back again, right? So when we forward all the packets based on what we call ECMP hash on the device, right? So it run the hash value for a float, and the float we may go to the certain device and link based on the random hash being generated. So that's where that if you for majority of customers, they get hash to the healthy set of device and links, so they were actually never impacted there. Right, but then for the small set of customers that got hash on the congested link device, that's where they saw impact. Right, and certainly the retry will be successful, right? Because this is congestion. This is not a completely broken connectivity. Right. But and a lot of time, if you retry, you will with the flow, right? You very much could be hashed onto a different set of device, right? So I think that's where this impact are contained in that bad set of link and devices.
So it's super interesting. So customers who had architected for retries would have experienced minimal impact as well?
You would definitely see smaller impact for sure.
Super. And then I think it's really important that you alluded to, it's a small percentage, but as the region is so big, as Frank, as you alluded to earlier, small percentages can still mean big numbers in terms of customer impact. But Frank, can I turn my attention to you again? How did we have issues with detecting, with correlating? I know it slowed down communications and when we told customers, but did our detections not fire? Were we late in the game with this? How do we manage to kind of detect and get hold of this incident?
No, I as soon as we saw the fiber cut, our systems automatically detected that we had an issue. But this is also a very, very large region, one of the largest regions in the Azure fleet. And so it did take a moment for us to understand where the overall impact was. But we did detect this immediately, and we ended up sending out a notification. And because of the size of the overall region and the criticality of this region for many of our customers, we chose to default to informing all customers that there was an impact that was happening within the region. So that, because we know that our customers also have their own disaster recovery and fallback systems that they can initiate on their own. And so we wanted them to be aware of what was happening. So if there were any measures that they could have taken on their own without waiting for Microsoft, they would have known that they could have done that. And if they were seeing some impact or to their services or to their traffic flows, retries, or any intermittent connectivity issues, then they would be aware that something was happening on our end. And we wanted them to avoid spending hours of trying to troubleshoot and see if there was something happening within their own environments, right? So we just defaulted to ensuring that everybody knew, because we do understand the criticality of this region for our customers.
Got it. That's a great point there. So we told everybody that was running any services in that East US region, even though, as we've just been described, most of the impact was limited to that one availability zone and was limited to less than 1% of the packets being impacted. Okay, that's great to understand. So next up, and Frank, maybe I'll stick with you. The post-incident review is talking about this auto mitigation tool, and it sounds like what that's supposed to do is to remove problematic devices or remove problematic routes from taking traffic. It sounds like that worked. It worked initially, but maybe didn't work later. Is that right?
Yeah, so as stated, so when we initially saw the fiber cut, traffic was automatically rerouted, and we were able to get some mitigation to the impact of the unplanned fiber cut relatively quickly. In the second incident, during that first mitigation, the tooling issue that we saw, and as Liwa explained, not having all of the spans that we were using isolated meant that some spans were left open on the devices, and our system saw that as, hey, that capacity, that link is still available. And when you have a fiber cut of this nature, and with the number of fibers that we have, they get repaired and respliced one by one. So as those fibers were respliced in the field away from our data center, and the connectivity was reestablished, our system saw that capacity was coming back and started to reroute traffic, but over a much, much smaller amount of capacity. And so that was the main driver behind the second window of impact that we saw.
So I'll leave the question open to either of you. I find it strange. I mean, we've spoken before, fiber cuts happen, they're a dime a dozen. Our systems are a bit resilient and pretty robust. And we have things like Azure Traffic Manager and Front Door, which reroute things automatically. When I was reading the PIR, it was interesting to know that engineers had to get involved and we had to pull levers and make things happen. Do our systems not just magically distribute and reroute things? I mean, immediately, I know there may be some delay, but I was interested to the level in which we had to get engaged.
Yeah, so
yeah.
Go ahead.
Yeah. No. Yeah, I mean, so yes, I mean, Microsoft, we experience like over 50 fiber cuts a day in different parts of our network on average, right? Some times of the year are more than others during hurricane season, typhoon season, summertime during construction season. So, we see this rerouting happening all of the time. But I think in this situation, the combination of events between one of our RH's devices already being down and this fiber being cut, and then the span isolation not happening correctly, our systems were not necessarily redirecting and rerouting traffic exactly the way we wanted. So we manually stepped in to ensure that to minimize the impact as quickly as possible for our customers.
Got it. Very good. Okay, that's good to understand. So well, there is some magic involved, but humans can help as well. Okay, so I want to pivot over to some of our repairs and learnings from this first incident. But first and foremost, Likwar, I think you were talking about this tooling failure, right? Yes. So what are we going to do to make sure that we don't take traffic before those links are ready to take traffic?
Yeah, so fundamentally, there is a software issue that we didn't handle the lock contention problem properly. Right, so that is since understood, and so this is something that we will fix it relatively soon. Okay. Right, so I think we believe that once that problem is addressed, we should be out of that territory.
Great. That's first thing up is to fix that. And so we said that was going to be fixed by May.
Yeah.
And then the second up, Franco, maybe we'd come back to you. The broader improvement here, or to kind of de-risk this class of failure, is expediting these capacity upgrades. So it sounds like we were already in the process of upgrading the data center or this whole region.
So we're in the process of going through a multi-phased overall tech refresh within this entire region to upgrade the entire platform and add more capacity. This is something that's been going on since December of last year. And so on top of this multi-phased approach for the tech refresh, there is a plan to increase the overall network capacity within the region to support continued growth of the region itself, both from a megawatt perspective and a pure volume of data center perspective. And so in order to ensure that when we fix this tooling issue from a span isolation perspective, and until we can address the unplanned design failure mode that we saw in the second impact, we are now pulling forward by about 7-8 months the overall capacity addition within availability zone 3, to ensure that while we push through and make the repairs that we've outlined, we have added capacity between now and then to serve as an added buffer for our customers to ensure that we don't see this again.
Super, and I can imagine, given it's one of our largest data centers in the fleet, it's not an easy thing to do. So I mean, customers see the scale of this, adding capacity like that, it's not an easy thing. I am interested to know that we talk to our customers about resiliency options. Okay. One of them is zones, and we speak about zones being kind of isolated impact. Here, what measures or what steps are we taking to ensure that if we have something like this, that it doesn't, I know the spread to other zones was small, but are we doing things to isolate to make sure that they're contained within zones? This was one of the repair items we spoke about.
Yeah, totally, right? So I think what we understand is that on the original hub device, right, there is a pretty deep fundamental design or thing that it didn't really provide the isolation we wanted, right? We understand the problem that it's deep in the both the software and the hardware kind of co-design level, but we know how to fix it, right? So I think that is something that actually we have been operating this for the last 7 years, right? And we look at it through all the past data, and we saw one occurrence 1 year ago, right, in a similar situation, but it has not really happened a lot, right? So this is certainly took us by a little bit surprise, but we understand the problem, and we think that we can solve this problem on our regional hub device level, right, without violating the basically reinforce the availability zone protection on the regional hub level.
Got it. So in that case, if there are customers that are watching this and they're saying, oh, here I was relying on running in 2 different availability zones. If they've watched this incident and thought, oh, I need to be multi-region, I need to take a wider footprint, you're saying that would be overkill, because actually we do think zones can deliver on this problem.
That's right. We believe we can definitely get back to the position that we can still protect the regional zone, right? So we're also working with our vendors together to look at whether there's a quick workarounds, but I think we want to solve this problem. This is pretty deep in the OS and hardware level, right? So we want to kind of get it to the deepest with the strongest protection possible.
Great. Okay, so I'm glad that we'll be beefing up availability zones to help kind of rely on more of that separation and isolation there. Okay, I've saved my last question for my co-host Sammy here. Sammy runs our incident communications team. So I want to ask, I know we touched on it earlier about over-communicating to the whole region. How did we do from a comms perspective? Any learnings from your team?
From a customer experience perspective, I think this was tough. The first part was we took too long to communicate it. It took about 2 hours for us to get that message out. And so for customers, initially when there's an incident happening, they want to know, is it a me problem? Is it an Azure problem? And so we don't want customers to start tearing down their infrastructure or invoking things. And so we try and tell customers, hey, this is an us problem, and we're working on it. And that usually provides some sort of relief. The second piece that we looked at is the accuracy. As we alluded to, we don't have the capability today to communicate to a single AZ. It's problematic for us, particularly in the networking space. And so we are making investments to be able to communicate to an AZ. Funnily enough, we can communicate to different racks or clusters, but not AZs because of the way data moves between them. And so we over-communicated by several orders of magnitude, particularly when we hear about the small number of failures that were happening. We ended up communicating to everyone. One of the challenges with this is that customers may panic, or there may be red herrings in there where customers think they're having an issue because an Azure have said this is an us issue, but once we mitigate, they're still looking for the problem because it doesn't happen. So over-communicating was a problem as well. We try to give customers updates about what was happening and so on. And for a period of time, we did quite well. And then as the incident tailed off, I don't think us as communications managers continue to feed customers. One of the things that we really try and strive to do is to give customers enough information, let them know everything that we know during the time. And there's a little bit of fog of war in there, but we want to let customers know, hey, this is what we know, so the customers can make business decisions and they can understand, okay, do I need to just go away for 2 or 3 hours, or do I need to fail out of the region, which can be very expensive. And again, including small details allows customers to understand where we are. It's been really interesting as we sit down and tell customers what's going on. It helps them understand, I know that I can fail out, or I can not fail out, or I can go for a longer lunch, or so on. And so I think overall we have work to do in our communications piece for our customers.
Got it. Sounds like we could have been even more transparent, which is what we aspire to be. Like we always say, look, the cloud can't be some black box. We have to make sure that we're keeping all impacted customers up to date. Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.